Next smallest,
35.
next smallest,
42.
42.
Forty.
2.
Next smallest,
61.
55.
So we what? Next smallest is what?
61.
Sixteen.
1.
Next smallest,
66.
next smallest,
6.
we have copied 66.
73.
70.
Believe.
3.
Next smallest,
75.
75.
next smallest,
80.
80.
next smallest,
94.
94.
next smallest,
99.
99.
next smallest,
100.
100.
is that 100 on the abacus?
Mm.
Mhm. So we shall have our
1.
0 under the leaf,
Yes, yes.
0 under the what? And 1. Mhm. So how many observations did we have we selected? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Are they 21? So we count and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So they are
21, yes.
solutions are 21. Okay, so we have plotted out a stem and what? We have plotted out a stem and leaf for our quantitative or numerical data. Okay, we have plotted out our stem and leaf for our numerical or quantitative what? Quantitative data. Then with that table, we can then plot out a few things. Have we finished putting down that table? Were we putting it down as we were trying to work out? Yes?
Not yet.
Not yet, okay. Tugume, yes, Tugume?
Sorry, how did you get 21?
How did we?
How did you
Count
get
your observations.
21?
How many are they? Count your observations. How many are they? How many observations have you generated? The random values. I mean the random numbers for X. How many are they? Now when you're counting, you count the ones under the leaf. How many are they? Because you're reading it.
21, I've seen. Thank you.
Yes. So let's put down that. Then we see what we can what we can plot from that. Make sure it's not register. Yes, Masood.
Sorry, sorry, sir. My internet was on, off, so I don't know how to create the stem and leaf.
Stem and leaf. We are arranging our observations or our data in a table. So we have said the leaf will only pick the ones with the idea of the abacus. Okay. And when we're organizing the leaf and stem table, we organize it systematically. You either start with the largest value or you start with the smallest value for a given data set. And for this case, we have opted to start with the smallest value. So that's why we're having 1 under the leaf. Then the next smallest was 10. And we know that the stem captures the tens, the hundreds, the thousands. So that 1 is under the 10 because you read it as 14, 16, 18. Then when you get to 20, you can't pick the 2 under the 10. So you can't say 10, 20. So it has to be 20. So you start on a different line so that it reads off properly. 20, 25, 26, 27, 33, 34, 35, 42, 55, 61, 66, 73, 75, 80, 94, 99, and 100. Yes, Joseph?
Yeah.
Yes.
I don't understand how you write the stem side and is it left side, side?
How you what?
How you write this stem side? How you consider them? It's like 1, 2, 3, those sides, and you have another side.
Have you just joined or you were on when we were discussing the idea the abacus?
Yeah. But I'm not understanding that abacus.
That is P2 work.
Okay?
P2, class 2. P1, P2, P3 work. And I said when you're plotting out that, we reflect or we borrow the knowledge of the abacus.
But it is long time to remember that.
You've forgotten the abacus?
It takes long time to that.
Hmm?
Yeah, abacus. I don't understand that.
You
Step
remember studying
and
something like this
this
in
is
P2 or P3?
I don't remember that work, sir.
The people used to do mathematics classes. So I have said, under the stem and leaf, the leaf will only pick values or record the values that are under the stem, picks these other what? These other values, the tens, the hundreds, the thousands, depending on how big a value is. Okay? Depending on how big a value is what? Is. Yes, Andrew.
I was asking, what do you do if you have like two numbers repeating themselves? How do you represent them?
Those are two different values. They are two different what? Values. So they are recorded differently. Just like in a class, you can score the same mark. So we only record 1 mark for one student. Okay.
How do you record them on the stem leaf table?
I'm saying that independent values. So assuming you have 11 and 11. This is 11, this is 11. They are two different what? Values. Okay. Now let's say we construct a frequency distribution table using our stem and leaf plotted. Using our stem and leaf plotted. One is that we identify out the smallest and biggest value for a given data set. Okay? We identify out the smallest and largest value for a given data set, or the least and largest, or minimum and maximum value. That's the first thing you do. Two, you determine their range value. Determine their range what? And of course, we know range value is the difference between the highest and what? The lowest. Now, for any exercise that you're going to do, the number of classes will be given to you. Okay? The number of classes will be availed to you. How many classes you have to group the work, they will be given to you. Then with the number of classes being given to you, you then determine what we call the class width, or what we call the class length. Okay? We determine what we call the class width or the class length. Now, we are saying that we determine the number of classes to you, and this is how, this is the principle that is used, or that we use. We use the principle of 2kth power greater or equal to n, where this kth power will be a value that satisfies that principle. N, this is total number of observations, isn't it? And in this case, our n is what? Our n is 21. Okay? So if we have 2 to the power 1, what do we get? 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, Are you sure? 2 to the power 5, 32. Hmm? So if k is 5, so we're saying that 2 to the power 5 is 32. 32 is greater than 20 what? 21. So 5 can call 5 for to be our. 2 to the power 6. 2 to the power 6. 64. 64 is greater than 21. 6 can also call 5. 2 to the power 7. 1. 8 is greater than what? Is greater than our 21. So 7 can also call 5. 2 to the power 8. 256. This also is greater than 1. So let me see which group gives us our, because we need to record all our information without leaving out any. Okay, so that's how we determine for the number of classes. Use that principle. Let's for the number of what? Of classes. This a hand up. This is who?
Yes, this is Simon. Right. I would like to know, I am somehow confused on the way. Like now the 2 power 6, 2 power 7, how do you come to the 2 power 7, which is 128? I want to understand it.
Get a calculator. 2 to power, get your calculator and have 2 raised to the power 7. What do you get?
I don't have a calculator.
I told you should be having calculator. I told you should be having calculator.
Can I use phone also now to bring the result?
If your phone can give you that, there's no problem. If your
Okay,
phone
so
can give
let's-
you that, no problem.
It will not, but you can show me, I think, practically, so that I have to understand it.
You get a calculator. These are calculations, not theory, not just reading. If you don't have a calculator, if I explain, you don't have. Because you should be looking at those buttons. I tell you, press this button and this other button.
It's okay. Let us continue. Maybe I will just catch up.
You get yourself a calculator. I requested you to be getting calculators because the next calculations we are doing, you can't just follow and understand. You should be pressing out or trying out as we also manipulate them. Otherwise, you just be a spectator. If we take 8, let me see, 8, our smallest value is what? 1. 11. Yes, Ivan.
Yes, Tim, can we go together? I have a calculator now.
You have what?
I have a calculator.
Do you know a power button on your calculator? Have you used it before?
Power button. Okay. There are some symbols here.
You press
You
2.
directly-
There is a button that is after the square button. That is button that is the V upside down. After that button, you go to log. Press that button that is V upside down.
Okay. I have pressed it, yes.
What do you get?
No, my brother. Anyway, I don't think
What have you raised to? Because it matters what you've raised to also. You've raised to power what? You give
I
me the
raised
answer.
power 2.
Give me the answer to power 9. What do you get?
Okay, 2 to power 9.
Mm.
I get 3.
Are you sure what you're saying? Are you very sure what you're telling us?
Okay, so let me take help from one of my friend here. Maybe he may be having some
Press
idea.
2, then you press that button. 2 raised to the power 9.
Yes. How do you
Who are coming from
how do you
class?
raise
Class. Those are who are coming. This is a class. This is one specific class. Give me the answer. 2 raised to the power 9. What do you get? 2 to the power 9. What do you get? We get 5. 2 to the power 9. This is 5, 1, 2, which is greater than 21.
Excuse me, sir.
Yes?
I beg your pardon on what K represents in the equation.
On how to?
On what K represents in the equation. I think I missed it out.
We are saying that K will be a number that satisfies this principle. Remember, we are raising 2 to power K. So whichever number we have raised to that satisfies this principle is the value of K. So it's from the value of K, that number we have raised, we see which one picks all our information, which one gives us all our values. Okay? 2 to power 10, what do we get? 2 to power 10, we get 24. 2 to power 10. Yes, we get 1024, which is greater than 21. I'm still looking for a value that picks all our data. 10, 9, see? Two, three, 5, 10. Okay, so I've been trying out, as I was asking you, I've been trying out, and if we take our K as 10, then we shall pick all our information. We shall record all our information. Okay, if we take we are saying let the number of classes be 10. Okay, because we have seen when we raise 2 to power 10, we are getting that, isn't it? We get 1 power than 24, which is greater than our observations that are 21, isn't it? Okay, so we have said that after we have all that information, then we can fit in. So which is our smallest value? Yes, Bwana Sozi. Mm. Five. From 2 to power 5. Mm. Okay. We have said the number of classes are set to you or are given to you by the examiner, or by if it's a research, then you'll get your scale, isn't it? Like if you're picking age groups, you'll come up with a scale of how you want to group your ages, isn't it? Okay, into how many groups. Now, when we are coming up with the groups for quantitative data, we expect a minimum of 5 and a maximum of 25 classes, depending on how big a data set is. If it's small, we expect it to be 5. It's more, if it's big or huge, then we don't expect you to go beyond 25 groups, to group our data into 25, beyond 25. Now, how do we come up with the appropriate number of classes for you? We have said that's the principle we use. Then we choose the one that records all our information without leaving out any. So I tested with the 6, was leaving out some observation, because from the information you've given, as I've said, it's random, it's not systematic. Because you're seeing the difference between the highest and the smallest is what? Is 99, isn't it? Okay? We are seeing that our smallest is 1. Our biggest is what? Is 100. Such that our range is what? 100 minus, giving us 99. So with our number, with the number of classes as 10, because I've been trying out here, okay, I want one that picks all our information. Our class, we've said our class interval, or what we call the class length, or what we call the class width, is given as range relative to number of classes. Okay, it's given as range relative to number of what? Of classes, such that our class interval or class length or class width is going to be our range value divided by number of classes, so that we have 99 divided by 10, giving us 9.9. Now, when we are taking number of classes, we take absolute value. We take the absolute what? We take the absolute value. So our class interval, or less, all we did is actually going to be 10. Now someone is going to ask, is it supposed to be that the number of classes should be the number of, It just happened, coincidence, that our classes are what? Are the same. From what you've given. Let me see if we do with the 20, if we do with the 5, 5, this gives us 19.8. 19.8, that is 19. That is 19, that is okay. That is 2, 3, 4, 5. Yeah, by the way, if we're going to use 5, I think let's use 5, so that people don't think that the number of classes should be the number of interval. You see, we have different thinking and the cramming. Some of you are crammers, not. You'll assume that number of classes should be the number of what? Class interval. Let's use 5. I not tested with the 5, I tested with the 6 and the other values. So if we use 5, B5, if we use 5 so that we help people who are crammers. We help people who are what? Otherwise, they will say, is it a must that the number of classes has to be equal to what? The class width. Forgetting it was just a coincidence. So let's avoid that confusion because we are after understanding and not cramming. So this is 5, and we're saying that this gives us 19.8. So that our class interval is what? 20. Because of that, isn't it? This is 19 point what? We know that this is the, okay, because I've said we take absolute what? We use absolute number. So let's take our K to be 5 so that we have our classes, we have our data harmonized into five classes.
Hello, sir.
Yes?
I'm not understanding what you're doing.
You speak loud so that your friends also hear what you're saying.
I mean the calculations you're doing. So from the class intervals, what are we trying to find?
We are finding the class interval, or what we call the class width, or what we call the class length. What is your question?
All right.
Okay. Now, in coming up with a frequency distribution table for quantitative data, we reduce the determined class interval by 1, and that applies only and only for the first class or the first group we are coming up with. Okay? We are saying when we are coming up with a frequency distribution table, we reduce the determined class interval by 1, and that applies only and only to the first class. Now, after I've gotten the first group, the remaining classes or groups we are yet to come up with, we actually maintain the actual determined class interval value. John, your hand is up. What is it?
A lot of confusion.
I can't hear what you're saying.
Yes, I am saying thanks for giving me opportunity. Based on the calculations, I don't know. I'm really confused on why we pick 5 or 10 as the class, as the number of classes. The reason why it is actually appropriate to be the number of classes. Because now I'm really confused on them. If I get it clear, if I.
What is confusing you?
The reason why we pick 5 or 10 is the number of classes.
The challenge, are you having where you're writing, or you're just attending class minus writing anything? Are you writing somewhere?
I'm writing, yes.
When I was giving you the steps, I gave you those steps. How many were they? This is not nursery where I'm going to tell you, can you write what I'm explaining? I expect you to have that sense that what is being explained needs to be written. That's why I did it deliberately. I didn't write what I was saying. I did it deliberately.
Martin,
I did it deliberately, not to write, not write those steps. Because why? I know some of you are just attending, you're doing other things. You're supposed to be attentive and note sense that what they're saying needs to be noted down. So if you noted down those 4 steps, you wouldn't be asking that how are we coming up with the 5? Because I say we give you the number of classes. And I explain how we choose for you the number of classes. And I say we use that principle of 2 to the kth power greater or equal to what? To n. And we are explaining how we get that. Simon?
Yes, Martin, your step are very okay, and we are really following it up. But to me, the confusion comes from this issue of truth power. Is any way truth and power, like truth power 7 that I was asking before, is any way where you can also break down it so that we understood it well, or is it only the calculator that we can use to get the solution? Is there another way, or use only
this is elementary mathematics, isn't it? Multiples. We used to do those things. Was it piece 5? Our exercise books used to have those what? A table. Eh? Yes. We're just doing a recap. So actually I was dodging, that's why I was telling you, we get for it the number of classes. So that because now that is confusing you now. Eh? The principle that we used to get for the number of classes. But those are multiples. We used to do them in primary, and it was mental work, isn't it? Yes. So we say the number of classes will be given to you. Now, if you have the number of classes, it means you have to identify your least and largest. Then get the range, then factor in the class what? Interval of the class with it for the class plain. Simple. I don't know why it is teasing your brains that is confusing you and okay. Now we were saying that when we are coming up with a frequency distribution table for the first class and only the first class, we reduce our determined class interval by 1, and we are saying that only and only applies for the first what? For the first class. Then after we have determined that first class or the first group, we then maintain the actual determined class interval. So let's try to present our data and see. So let's try to do our frequency distribution table. So we say the first column picks the name, isn't it? So we're having classes, yes? Now, when we are coming up with the classes, or when we are coming up with our frequency distribution table, the smallest value of figure or number for a given data set appears first. Okay? The smallest what? The smallest value of figure or number for a given data set appears what? So which is our smallest value for this data set that we're using?
1.
It is 1. Now, we have said that in coming up with a frequency distribution table, we reduce our determined class interval by 1. And that applies only and only for the first what? For the first group. So what was our determined class interval? What was our determined class interval? 20. 20 minus 1? 19. So it means moving from 1, the next we shall have 1 plus 19 giving us. So we have determined that first group. We have determined that first what? That first group. And our interest is for us to harmonize this data into 5 classes, isn't it? Or groups. Now, we have said once we come up with the first group, where we have reduced 1, the remaining we shall actually use our actual determined what? Class interval. Implying from 1 to the next group, we shall add 20, giving us 21. From the group of 20 to the next, we shall add 20, giving us
40.
From the group of 21 to the next group, we shall add 20, giving us
41.
41. From the group of 40 to the next, we shall add 20, giving us 61. From the group of 41 to the next group, we shall add 20, giving us
60.
From the group of 60 to the next group, we shall add 20, giving us
100.
Those, we have to come up with 5. How many do we have? 1, 2, 3, 4. From the group of 61 to the next group, we add 20, we come up with 81. And from the group of 20 to the next group, from the group of 80 to the next group, we add 20, it gives us
100.
It gives us 100. Now, values that are running, okay, those values that are running from 1, 21, 41, 61, and 81 are what we call the lower limit values. Okay, those are what we call the lower limit what? Values. And values that are running from 20, 40, 60, 80, and 100 are what we call the upper limit. So our frequency distribution table for quantitative data gives us 2 limit values, the lower limit value and the upper limit value. So that's the first column that we have generated. Our second column is what? The tallying, isn't it? Yes? Our next column is
Hello, sir.
the tallying, yes?
You said that the first class will reduce by 1. I couldn't understand that. So you mean to say 1 minus 20, or we say 20 minus 1?
What was your class interval?
It is 20.
And what are we reducing?
Reduced by 1. That's what you said.
Yes, and what do you get?
That is 19.
Then 19 plus 1, because we are adding, our starting value is 1. So what our smallest value for data set we got was 1.
Yeah, it was 1.
So 1 plus 19?
20. Okay.
The actual class interval there is 20. That is just a simple principle. Count from 1 and 20. How many values do you have in between there? 1 inclusive and 20 inclusive. How many values do you have? There are 20, which is our class interval. The other is just a logic or principle to help us harmonize our data.
All right.
Now, what does it mean? It means we are looking out for values running from 1 to 20. We are going to look out for values running from 21 to 40. We are going to look for values running from 41 to 60. We are going to look out for values running from 61 to 80. And we are going to look out for values running from 81 to 100. So that's why I say in harmonizing our stem and leaf, it's good we harmonize it in a systematic pattern or order. So that when you're extracting out these groups or classes, it's as easy as enjoying your best staple food, isn't it? So let's look out for values running from 1 to 20. So we have 1, 14, 16, 18, and 20 itself. So how many are they? How many are they? So this is 1, 2, 3, 4, 5. Next, we are tallying out values running from 21 to 40. How many are they? Go to your stem and leaf. You have 25, 26, 27, 33, 34, 30. How many are they? Use your own table there. That's why you plotted it. 1, 2, 3, 4, 5, 6. Next, we are looking out values running from 41 to 60. How many are they? 41 to 60. We have 42, 55. Next, we are looking out for values running from 61 to 80. How many are they? 61, 66, 73, 75, and 80. How many are they? And lastly, we are looking out for values that are running from 81 to 100. We have 90, 4, 99, and 100. So these are 3. Then our frequency, this is 5, 6, 2, 5, and 3. So 5 plus 6, 11 plus 2, 13 plus 5,
18.
18 plus 3,
21.
How many were observations? There are 21. Then we also saw from the earlier table that we expect 4 standard columns, isn't it? The name or the first column, the tally, the frequency, and what we call the percentage or relative frequency. The relative frequency, or what we call the what? The percentage, and we say that that is frequency for a group divided by total frequency times 100. So we have 5 divided by 21 times 100. What you get? We get 23 point
23.8.
81, isn't it? Two decimal points.
Yes.
Next is the 6 divided by 21. The answer we get is
28.57.
20.
8.57.
57. Good. Next, we have 2 divided by 21. The answer we get times 100. What we get?
9.52.
9.52. Good. 5 was giving us 23.81. Then 3 divided by 21. 14.
14.28. 29.
29. So that when we add that, we should be getting, this should be giving us 100%. That should be giving us 100 what? Yes, Innocent, like you're saying something, your microphone is on by mistake.
Sorry.
Okay, so let's put down that table. Then we see which other columns can we add from that table. question. Have you gotten that point? Your smallest value appears first. Then these other principles follow. Your smallest value appears first, but we know for the first class or group we are coming up with, we reduce the determined class interval by what? By 1. It still gave me this data set, so that's what. So you're now contemplating 1, and again you're subtracting 1 from the class interval, isn't it? And 1 is the smallest one. Okay. Tamale.
Good morning.
Morning, how are you?
I want to take you back to the class interval, confirm something.
class?
Interval. You said for the first class, you reduce by 1 and then add 1 again.
We're not adding 1. That's what I was just explaining what Tracy was asking. What is confusing you is the smallest value for what we are dealing with is 1. And for the first class, we are subtracting 1 from the class interval.
Yes.
That's what is confusing you. But I've given you a scenario where we say, assuming our first class was 10, then it means you would have 20 minus 1, isn't it? Which is 19. So it will be 10 plus 19. Then for the other classes, you maintain the 20.
Now, for the next classes, could you help me put back on the... Why do you start with 21 instead of 20? For the second class, yes.
From the first class, from that first group to the next class, you're having an interval of 20.
Yes.
So that have to be 20. When you add 1 plus 20, you get 20.
1 plus 20. Because you start with 21.
Okay, what's the difference between the 21 and the 1?
21 and 1 is 20.
What is your class interval?
20.
So what have you maintained? What interval have you maintained?
20.
So you expect 20 plus 1 to be 20?
No, that's not it. It's supposed to be 21. Okay, understand. Then,
okay,
the percentage.
The percentage is 5 divided by 21 times 100. That's why I expect you to have calculators so that you feed in and tell us the answers you're getting.
5 divided by 21 times 100.
Yes. So
You
it's
divide
frequency
by
of the class divided by total frequency times the 100, because we are. So what do we get? If you have a phone, still a phone can give you that. That is not very complex.
Martin.
Then we maintain 2 decimal points, isn't it? Because that value gives us 23.8095, isn't it? 2 decimal points, we get 8 what? 1. So we do that for the same until we generate all our relative what? Our relative frequency.
I still don't get it. It's the rate.
Pardon?
What do you multiply exactly?
Why?
What do you multiply? The columns you deal with. 5 times what?
We are saying 5 divided by 21. Your total frequency is 21, and you're getting a percentage of that specific group. In other words, you're trying to have a percentage or a percentile presentation of your distribution of your frequencies.
Okay.
Okay, let's continue.
All right, thank you. I understand it.
We're creating a column of cumulative frequency, and I was asking what is cumulative or what is to cumulate. What is cumulate? Successive what? addition. So what is our first cumulative value? 5. Next, we shall have 5 plus 6 giving us. Next, we shall have 11 plus 2 giving us. Next, we shall have 13 plus 5 giving us. And lastly, we shall have 18 plus 3 giving us. And our total frequency is what? 21. Let's come up with what we call the class boundaries. Class what? Now, when we are coming up with a class boundary, when we are coming up with a class what? We are guided by the principle plus minus 0 point what? Plus minus 0.5. Now, we said that the first column gives us two limit what? Two limit values, isn't it? It gives us two limit. It gives us two limit values, yes? Now, it means that our plus 0.5 is mapped the upper limit value, and our minus 0.5 is mapped the lower limit value, okay? What is our first class boundary? We are mapping the plus 0.5 to the upper limit values, and we are mapping the minus 0.5 to the lower limit values. So give me the first class boundary. It's what? So here I shall have 0.52, 20.5. Then we shall have 20.5 to 40.5. Then we shall have 40.5 to 60. Then we shall have 60 to 80. Then we shall have 80.5 to 100.5. So we have generated our class boundaries. Okay? We have generated our class what? We have generated our class boundaries. And the last column that we add for our quantitative frequency distribution table is what we call the midpoint or the class marks. What we call what?
Sir, I'm totally lost. 0.5 to 20.5. How do you generate the points?
We said we map minus 0.5 to the lower limit values, and we map plus 0.5 to the upper limit values. So you map for me minus 5, minus 0.5 on the lower limit values. What is your first value? In other words, we are saying 1 minus 0.5. What do you get? 1 minus 0.5, what do you get?
I think, sir, she was asking how you came up with the 0.5. Maybe that was her question.
Please, when we talk of we're following this principle, don't see. We are looking at basics. We're not proving formulas here. We are looking at what? So when I say we are guided by this principle, isn't it? So that's why I've told you have to be attentive. Don't think I'll tell you, because when I was writing this, I said when we are coming up with class boundaries, we are guided by this principle, and I wrote it down. Isn't it? So if you just see the plus minus 0 there when you are not following, then you begin asking what is 0, what is plus minus 0 point what? Okay? So Betty, I was asking 1 minus 0.5, what do you get?
0.5.
20 plus 0.5, what do you get?
I don't have a cursor.
So you expect me to get you one?
It is 19.5.
20 plus 0.5, you get it's 19.5.
You get 20.5,
It's
20.5.
20.5. It's 20.5.
Okay, so having class marks. Let's generate the class. Let's generate the column of class marks. Okay, so that's how we generate the class boundaries. We are guided by the principle of plus minus 0.5. And I'm saying the minus 0.5 is mapped to the lower limit values. I've told you what are the lower limit values. I've told you which are the upper limit values, if you've been following. Then we can add a column of what we call class marks or what we call midpoints. You can call it class marks or mid what? Or midpoints. Now, in coming up with the class marks or the midpoints, you can use your classes or you can use your class boundaries. That is if you have the two in one, probably because each of those other column we add, we use it for certain activity. Okay? So it's the average of either a class or class boundary. Okay? It's the average of either a class or class what? Or class boundary. So we have 20 plus 1, what do we get? 21 divided by 2, because we're adding two values. That's what you mean. Average means you're dividing by how many values you're adding, isn't it? So we're adding 1 and 20. Then the answer we get, we divide by 2, since we're adding two values. What do we get? We get 10?
10.5.
Now, we have seen that our class interval is what? Is 20. So after you've gotten the first midpoint, just keep adding your interval. Keep adding what? Your interval. You get the same. Okay, let's have 21 plus 40. What do we get? 61 divided by 2. 61 divided by 2.
40.5.
41 plus 60. What do we get? 101 divided by 2.
50.5.
50.5. 61 plus 80. What do we get? 141 divided by 2. What do we get?
70.5.
And lastly, 81 plus 100. 181 divided by 2.
90.5.
So it's what I was telling you. You get the first midpoint, maintain the class interval. The first midpoint is 10.5. Keep adding 20. What do you get? 30.5 plus our class interval of 20. 50.5 plus our class of interval of 20. 70.5 and plus our class interval of 20. Giving us 90.5. So that's how we harmonize our data, our quantitative or numerical data into a table. Now, from this table, we can now plot out graphs. Okay? From this table, we can now plot out what? Graphs. And that will be our next week is activity. Which graphs can we plot out from this table? Using which column to get which graph and get which what output. So next week we shall see how we do graphs from our table. So just note it somewhere. When I ask you for this table, be in position to give it to me. Okay, because the most likely to clean out this relative so many too much space here. Okay, so that's what we had wanted to try and do today. And of course, these are things that require you to be doing practice so that you can understand them better and more. Okay. Then I expect you also, as you're attending class, you have somewhere you write. You can have your full scopes, you can have a book. Otherwise, if you just watch like you're watching football, then when it comes times of reading for the tests, okay, the test, since it will be online, some of you can copy. But the exam where you sit in a class here and have to scratch the head in 3 hours, you don't have nothing to revise, then you'll be finished. Okay, so I expect you to be having a book alongside, or where you're writing, as we are discussing. So that's why I try as much as possible not to be fast, but to keep giving you time to write. Right. For those, okay, it's also very okay. But I expect you to be noting a few things down, so that as you're doing your personal reading and revision, you try to link what we were discussing in class and recall. So if you think you just go to ChatGPT, that one is an automatic 0, no wasting time. Because it reports to you. It cannot, because I not give you, you just, some of you can't edit, it brings those good things, then you, that's an automatic, without even wasting time. Okay, so we meet next weekend, next week, and next month. Happy New Month. Our friends who are the Muslim brothers and sisters, we wish you, this is what, Ramadan or?
Excuse me, sir.
Yes.
Martin.
Yes, I was just asking you if this lecture is being registered.
You ask Mr. Sozi.
Excuse me, Mr. Martin.
Chief.
All right.
Mr. Sozi, I requested him to be to help us record if he can manage.
Mr. Martin?
From my side. Yes, please.
And the next thing, meeting.
One person at a time.
Okay.
Yes,
I'm requesting if you could share with us the class, the slide or note on WhatsApp. It will be helping because the client things is not.
If you've been observing, I'm using a tablet, which is a write-in. So I'm just writing in. They're not slides. If you've observed, I'm using a write-in tab. So it's more or less I'm using an advanced white kind of board whereby you're just writing in. That's why I expect you to be also writing. Because as you've seen, as I keep writing, I rap. So they are not slides. So you must
Mr.
have,
Martin?
you must have a book. But Mr. Sozi is helping us record the classes. So I think he'll be sharing the links with us. That's if he's successful with the recording, then they can be shared out.
Mr. Martin?
Yes, please.
I would like to be jump started on something as far as tests and exams are concerned. Okay, for the tests, I know we are going to do them online, but for the DL students, how are they going to conduct exams, final exams?
Final exams, DL students, you do online, but you're supervised. You turn on your camera, you work. Okay. Each one of these is assigned a supervisor. So you work, you share your screen, your camera is on, and we see whatever you're doing. And you're working within 3 hours, no extra time given to you.
Oh.
So I always encourage, if you're within Kampala, you can come and do physical exams. Even if you're DL. Because once the system works you out, you're finished. Because it's time. Once the system locks you out, you're finished. So I always advise if you're around, if you're within Kampala, and the good thing we are our exams now are from last semester they were sessioned into two. Those are starting weekends. You are doing on Friday, Saturday, and Sunday because those are the weekend kind of because you can easily sneak out and okay. Then the regular students we are doing from Monday because they are full. All that move will also be maintained going forward. So that weekend students are doing. So if you're within Kampala, weekend is weekend. You can disappear from office. Come and do exams, go back. Otherwise, online one you have to be where there is network. Going you off, it means you're cheating. Yes. Why should it go off? For us, we may not know that power is going off. It's an exam. They have to make sure all those conditions are constant. Otherwise, anything beyond that, your exam will not. Your exam will not be accepted because those people they are monitoring the system as well, so they know who is going off, who is not on. Automatically, you can't upload the exam because no one has invigilated you and you're being off. Because each student is assigned someone to supervise. They are overall supervisors who monitor the system.
Hello, Mr. Martin, I have a question.
Okay, we pick from there.
Excuse me, Mr. Martin.
Yes.
Thanks, sir. Me, this is my first time to attend a class.
For us to have been attending, this is week one. This is about our week 5, week 4. Week 5, yes, actually week 5.
Okay, the
of course, the
question
first
is,
week you don't count it because that is the people are reporting. Yes.
okay. Yes, good enough. You shared Mr. Suzu's number. I'll get in touch with him. But a quick one. Do we have some assignments you have shared before?
Not yet.
Okay, thank you.
Mr. Martin, I have a question. The question I have is in Planet, they are on Planet.
With?
There are those
Planet, unless if I've told you to do anything on Planet, that one don't waste time. Because from week 3, what is there is not for this month.
Okay.
Okay. So what is on Planet is not for this module. So that's why I've not told anyone to do any Planet activity. Because after all, we are meeting every weekend. So if there's anything, I will upload it there myself for you to do.
Martin. Martin?